Hi there. In our last section, you learn about the independent event and how to find the probability of an independent event. In this section, you are going to learn about the law of total probability and Bayes' theorem. So let's begin. The law of total probability. As you can see, I'm considering two sample spaces and they are basically the same sample spaces. The reason why I'm considering two same sample spaces because I want to show you how exactly we can derive the law of total probability. So let's first consider the first sample space. So what I'm going to do, I'm going to partition the first sample space in three. So this is my first, second and third partition. Let the first partition is B1, second one is B2 and third one is B3. Now let's move to the second sample space. So what I'm going to do, I'm going to consider event A. This is my event A. Now I'm going to combine these two sample spaces because originally they are the same sample space. So when I combine these two, I will get a picture something like this where I'm dividing A in 1, 2 and 3 pieces. So this is my A1, this part is A2 and this part is A3. If you remember, the first part was B1, so it's right here. Second part from the first sample space is B2, which is over here. And the third part is B3, which is over here. Now, what I want to do, I want to find the relation between B1 and A for A1. And in the same way, I want to find the relation between B2 and A for A2 and B3 and A for A3. So let's write the relation. I want to find the relation for A1. So if you look at A1, A1 is common area for B1 and A. So I can write A1 is equal to A intersection B1. In the same way, A2 is A intersection B2. So I can write A2 equals to A intersection B2, and in the same way A3 is A intersection B3. Because if you look at the picture, you will see that A1, A2 and A3 are the common area or space between B1, B2 and B3 and event A. Now what actually the A is? A is basically A1, A2, A3. So I can write A is equal to A1 plus A2 plus A3, and the probability of A is equal to probability of A1 plus probability of A2 plus probability of A3, and I can replace A1 by A intersection B1, A2 by A intersection B2 and A3 by A intersection B3, and if I do that I can write PA is equal to over here. If I further simplify, I can write PA is equal to conditional probability of A given event B1 times probability of B1 plus conditional probability of A given B2 times probability of B2 plus conditional probability of event A given B3 times probability of B3, and basically this relation is known as law of total probability. Now what I'm going to do, I want to consider the law of total probability to create a general relation for K partitioning of a sample space. So let's consider K partitioning of a sample space as such as B1, B2, B3 all the way to Bk, and let A is any event associated with the sample space S. So I can write probability of A1 plus probability of A2 plus probability of A3 all the way to probability of AK is equal to 1 because sum of all the probabilities are equal to 1, and I can write PA is equal to probability of AB1 plus probability of AB2 plus probability of AB3 all the way to probability of BK. And if I further simplify this, I will write probability of A is equal to conditional probability of event A given event B1 times probability of B1 plus conditional probability of event A given event B2 times probability of B2 plus dash dash all the way to conditional probability of A given Bk times probability of Bk. And this is my general form of the law of total probability. At your grade level, you are most likely going to use 2 or 3 partitioning of a sample space. So let's write a formula for the 2 partitioning of a sample space. So if we do that, we can write probability of B is equal to probability of B intersection A plus probability of B intersection A dash, where A dash is the complement of A. And if we further simplify, we can write probability of B is equal to conditional probability of event B given event A times probability of event A plus conditional probability of event B given complement of event A times probability of complement of event A. And at your grade level, you are most likely using these two very often.